In this video, I am going to solve this second order constant coefficient homogeneous differential equation, and the equation is y double prime plus 4y prime plus 3y is equal to 0 with initial conditions y of 0 is equal to negative 2 and y prime of 0 is equal to 1. Second order constant coefficient homogeneous differential equations, they have the following structure: a y double prime plus b y prime plus c y is equal to 0. Here a, b and c are real numbers. They are coming from the number line. Now we make the assumption here that the solution for this type of differential equation is of this form: y is equal to e to the power rt, where r is some number. So our objective here is going to be to find out what r is. So after making the assumption, what we can do, we find the derivative of it. Y prime is going to be equal to r e to the power rt, and y double prime is going to be r square e to the power rt, right? Now if I take these three values and plug it into this equation, what's going to happen? We are going to get r square e to the power rt plus 4r e to the power rt plus 3 e to the power rt is equal to 0. If e to the power rt is factored out, I'm going to have r square plus 4r plus 3 is equal to 0. Obviously, e to the power rt is not equal to 0. So that means this has to be equal to 0. And this, by the way, is called the characteristic equation associated with this differential equation. Now we just need to solve it, which is pretty straightforward. R square plus 4r plus 3 is equal to 0, or r square plus r plus 3r plus 3 is equal to 0. I'm just factoring it. Between the two, I could factor out r. That's going to give me r plus 1. And between these two, I could factor out with 3. That's going to give me r plus 1. And that is equal to 0. So I have r plus 1 times r plus 3 is equal to 0, or r is equal to negative 1, or r is equal to negative 3. So my solutions are going to be, let's say y1 is going to be equal to e to the power negative t, and y2 is going to be e to the power negative 3t. Okay? Now, the general solution for this equation is going to be a linear combination of these two, which is going to be y of t is equal to c1 times y1 plus c2 times y2, or c1 times e to the power negative t plus c2 times e to the power negative 3t. And then if I take the derivative of it, it's going to be y prime of t is going to be equal to negative c1 e to the power negative t negative 3 c2 e to the power negative 3t. And now, in order to find the constant c1 and c2, I'm going to use this condition and this condition. So if I apply the first condition to the y of t, I'm going to get c1 plus c2 is equal to negative 2, because e to the power negative t is going to be e to the power 0, which is 1. Similarly, e to the power negative 3t. Using the second condition, which is this one, and applying it right here, we get y prime of 0, which is going to be negative c1 negative 3 c2 is equal to 1. Now I can just add these two equations, this one and this one. So it's going to give me c1 plus c2 is equal to negative 2. That's going to give me negative 2 c2 is equal to negative 1, or c2 is equal to 1/2. And c1 plus c2 is equal to negative 2. c1 plus 1/2 is equal to negative 2, or c1 is equal to negative 5 over 2. If I plug it into this equation, then I'm going to get y of t is equal to c1 negative 5 over 2. So negative 5 over 2 times e to the power negative t plus c2. c2 is 1/2 e to the power negative 3t. So this is going to be your solution to this differential equation with these two initial conditions. I hope that this discussion was helpful. Thank you very much.